Hey guys, this is Coach Lowe, and we are going to talk about systems of linear equations. So open up your Chromebook and grab your notes, and let's roll. All right, so systems, we talked about linear equations in the last video. Now we're going to talk about systems of linear equations. So what we mean by that, a system of linear equations would be two or more equations that we can graph or we can just solve, but they have common variables. So like they have x and y, or they could even have three variables. We won't work with those today. And you can have more than two equations, although we're going to work with two equations, two variables today. All right, so in this system of equations, we're going to try to find solutions. All right, so the solutions to a system, we can have three options. We can have an ordered pair for the solution. So what would my two lines look like if I say their solution is an ordered pair? Yeah, you're right. If my solution is an ordered pair, that means my lines are crossing. So let's go ahead and write ordered pair, and let's write lines intersect next to it. And then let's draw a little picture so we'll remember what that looks like. So just sketch a couple of lines crossing. They don't have to be perpendicular. They just need a point where they cross, and that's the point of intersection. So they intersect at one spot, they have that point in common, and so that's my point of intersection. So ordered pair is my solution. All right, number two. What else could these lines do? So besides cross, what else could happen with these lines? They could run parallel to each other. So my lines could be parallel, and we know that parallel lines, what do we know about their slopes? Exactly, they have the same slope. So looking at those lines, are they ever going to cross? Because remember, when we look for the solution, we're looking for a point that they have in common. So are those lines ever going to cross? No. So this would be no solution. And when we're looking at no solution, that means we're dealing with parallel lines. All right, so they are never going to cross. I won't have a solution for those guys. All right, number three. So I have lines that cross. I have parallel lines that have the same slope. So what would be the other option? They're the same line. So when I graph this line and then I graph the second line, they're right on top of each other. It's the same line. All right, so that would be infinite solutions because how many points do they have in common? All of them, right? Yeah, exactly. So this would be the same line. All right, so those are my three solutions. We're going to look at those today. I have ordered pair because the lines are intersecting. So I have lines that intersect. My solution is an ordered pair. Number two, I have parallel lines, so there's no solution. They have the same slope, so they're never going to cross. And number three, they end up being the same line, and there's infinite solutions. All right, there are three ways to solve. Well, there's actually more, but there are three ways that we're going to look at today. And actually, we're going to look at two of them, and then we're going to look at one of them the next time I see you in class. Number one is by graphing. And we graphed linear equations yesterday. And so when you come back to class, I'm going to show you some stuff on the graphing calculator, how to find points of intersection quickly. We'll pop those on the graph. We'll look at them. We'll analyze it. We'll do all kinds of fun stuff with it. So we'll check that out when I see you again. So let's go on to number two. Number two, the method is called the substitution method. So think about maybe sports where you have a sub. So I'm thinking about basketball and there's a sub at the scores table, and that substitute comes in and takes the place of another player. So that's exactly what we're going to do. We're going to let part of the equation come in and take the place of another part. So like we may solve for y, and we'll let that expression that we've solved come in and take the place of y in the other equation. I'll show you how to do that. And then the third one is called elimination, and this is kind of a game to me. So those are the three of several methods that we can use to solve systems of linear equations. So we're just going to work a couple of these. Let me show you substitution, and then we'll do elimination and be good to go. All right, so let's talk about substitution first. All right, so I told you as we're looking at this substitution method, we're going to think about replacing. All right, we're going to think about replacing a part of the equation. So let me give you a system of equations and we will check this out here. So here's example number 1. Let's go with x equals 4y plus 22. And 2x plus 5y equals negative 21. All right, so when we're thinking about using the substitution method, we want to look at, or when we're choosing our method, let me say it that way, we want to look and see what our equations look like. If I have one of the two equations that solves for x or y, or one of the variables, then I would like to use the substitution method. So as I look at this, do you see that y is, or x is on one side and then everything else is on the other side? So this equation has been solved for x. So here's what I would like to do with this. I want to take this stuff right here and replace x with it because it says x equals 4y plus 22. So I'm going to pop it right there where that x is. All right, so if you want to pause the video and do that without me, go right ahead. All right, so it looks like this. 2 times 4y plus 22 . All right, so I've taken this and I've plugged it here, plus 5y equals negative 21. So the bottom equation is not going to change any part of it except where that x is. So where x was, now I've replaced it with 4y plus 22. So I have substituted in for that. All right, now we're going to solve. Notice, now I have a single variable. I'm just dealing with y's now. So I'm going to go ahead and distribute the 2 through to the 4y and the 22, and then we'll work on what we did yesterday as we were solving equations. So 2 times 4y is 8y, plus 2 times 22 is 44, plus 5y equals negative 21. All right, so from here, we can solve. So our first step in solving equations, remember, we combine like terms. We look for like things. And so I see I have an 8y and a plus 5y. So I'm just going to throw those guys together. So 8 plus 5 is 13y plus 44. Uh-oh, my pen quit. Plus 44 equals negative 21. All right, so now let's go ahead and solve. Let's go ahead and solve here. So I'm going to move the 44 over and then divide by 13. Those are my steps to solve. Remember, moving, adding or subtracting to move, and then multiplying or dividing to get y by itself. So I'm going to subtract 44 from both sides. It's a lot of coloring going on down here. And so 13y equals negative 65, and then divide by 13 on both sides. So y equals negative 5. All right, so now here's the question. When y is negative 5, because right now I have this, when y is negative 5, what is x? So I could go back to either one of these two originals and plug in negative 5. And I would like to do it in the first one. So because it's just going to be a little bit faster since x is already isolated. So 4 times y is negative 5 plus 22. So now I'm going to go ahead and solve this for x. So 4 times negative 5 is negative 20 plus 22. So x is 2. So 2 -5 is my solution. So if I were to graph these two lines, which means I would need to get these guys in y equals, or I can do a quick graph with the intercepts, put them on a graph, and be very careful as I'm graphing. This would be my solution. This would be where the two lines would cross at 2, -5. All right, let's go to the next example. All right, so example number 2 is going to be the game method. And the game method is the elimination method. All right, so for the elimination method, we are going to try to eliminate a variable. So here are your two equations if you want to go ahead and write these down. And then I'll show you how to spot if you need to use the elimination method. So let's go 4x plus 5y equals -11. And then 2x plus 3y equals +11. 2x plus 3y equals +11. All right, so in order to do the substitution method, now you don't have to do this, but what I look for when I do substitution method is y solved or is x solved, or can I solve for either x or y quickly and cleanly. So if I try to get x by itself here, think about it, I'd have to move the 5y over, divide by -4, that gives me fractions. If I do that with 5, same thing, I get fractions. If I want to solve this one for x, yuck. All right, so I don't really want to do the substitution method. I don't really want to bust out with a graph either. Elimination method means we're going to try to eliminate the x or the y's. So here's your goal in the elimination method. One of these numbers, so as I look at the 4 and the 2, so one of the sets of numbers either in front of x or in front of y need to add to be 0. So in other words, if this is a -4, this needs to be a +4. If this is a 5, this needs to be a -5. No way to get that, but we can go multiples. So the first number that these two have in common would be 15. So this would need to be either positive or -15, and then this one would need to be the opposite. You can multiply the entire equation by any number. You can divide the entire equation by any number. You can do both equations by a number if you want to. So I think I'm going to go ahead and try to get rid of these guys. So is there a number I can multiply by 2 to get a +4? I want a +4 because this is a -4, and absolutely we can multiply 2 times 2 and get 4. Now listen very carefully, you have to do the entire equation by 2, not just the number in front of x, the whole equation. All right, so let's do that. We're going to leave the top equation just like it is, -4x plus 5y equals -11. And the bottom one we will multiply by 2. So that gives me 4x because 2 times 2 is 4. And then I'm going to multiply 3y by 2, which gives me 6y. And then multiplying 11 by 2 gives me 22. All right. So here's what my equation looks like now. All right, now you're going to play the knockout game. So draw a line underneath these, and we are going to add these guys together. Okay, so we're going to add the columns. So you're going to go straight down and add. I have like terms stacked up underneath each other, so we're going to go straight down and add. So the first one, -4x plus 4x is 0x. So this is gone. All right, now let's add the next one. 5y and 6y is 11y. And then let's add the last one, -11 plus 22. -11 plus 22 is +11. All right, now we can solve for y. To get y by itself, we just need to divide by 11 on both sides. So y is 1. All right, I'm going to go plug that back in. You can plug it into either equation to solve. So I'm just going to grab this second one, 2x plus 3y equals 11. And I'm going to plug in 1 for y. So 2x plus 3 times 1. It's a math bandit coming in to try to color on my problem. Stop it, math bandit. Okay, so I'm serious. All right, so let's keep going here. So 2x plus 3 equals 11. There's that bandit again. We are not going to be derailed from this. All right, I'm going to subtract 3 from both sides to solve. And when I finish, I get 2x equals 8. or x equals 4. All right, so when x is 4, y is 1, which means I have a point of intersection at 4, 1. Those two lines are crossing at 4, 1. All right. So as you come back to class, we'll do some application problems on this, some real world examples. We're also going to look at, okay, what does it mean when there's no solution or infinite solutions? What will it look like? Because we will not get a point of intersection, will we? We won't get a point. So it's going to be a little weird. I'm going to let you guys work on that when you come back to class. So be thinking about that. Remember, if you have any questions, make sure you write those in the margin. If you need to go back and watch any part of this video, please do that. All right, guys, I'll see you soon. This is Coach Lowe, and I'm out.